my name is James Russell. I'm going to be talking to you today about African easterly waves and tropical cyclones and their relationship between those. So African easterly waves are synoptic scale disturbances that move across Africa and then over the Atlantic, where they're typically thought of as the main tropical cyclone precursor. And so our aims and goals today are to extend and examine the statistics relating these two, and then to use these statistics to improve tropical cyclone formation on a seasonal basis. So what we're going to do is we're going to define a number of numbers, and these are all derived from the National Hurricane Center tropical cyclone reports. First is the genesis number, which is the number of tropical cyclones directly forming from African easterly waves, so where the African easterly wave is the main precursor. And then the second is the contribution number, which is the number of tropical cyclones where African easterly waves had a positive influence on tropical cyclone formation. And then we divide these by the total number of tropical cyclones to gain a fraction. And so this is what's shown up here. This is the fraction along the y-axis, season along the x-axis. And then this in red is the genesis fraction. This in blue is the contribution fraction. And so on average, 61% of tropical cyclones form directly from African easterly waves. And this is fairly consistent with previous literature. But then if we include the contribution fraction, 72% of tropical cyclone formations are actually affected by African easterly waves. And this is a number that hasn't previously been reported in the literature. So now we wanted to look at the relationship between African easterly waves and TCs from a seasonal forecasting perspective. And so what we're going to do is we're going to use the error-interval analysis. We're going to filter that to gain African easterly wave anomalies. And we're going to calculate the eddy kinetic energy, or the wave kinetic energy from that. And then we're going to correlate that wave activity, basically, against the genesis number that we just talked about. And that's what's shown in the shades here. What we have here is a cross-section, height against latitude, and this is for an average over Africa and the Eastern Atlantic. And in the contours, we have the eddy kinetic energy. So here you see the storm track of African easterly waves, here and here. This is the southerly and northerly track. And what we see is that there's a weakness or a low correlation right at the peak of those waves, which is surprising given that African easterly waves typically thought of as the main precursor to tropical cyclones. Where we do see an associated correlation, though, is in the low levels, and this is associated with the circulation in the low levels of the African easterly wave. The African easterly wave circulation actually extends all the way out here. We just have weaker circulation in the low levels. So we wanted to look at this region in a bit more detail. So what we did was we calculated eddy kinetic energy for each year in that box, and then we resampled that 100,000 times, basically generate 100,000 new climates. And so what this gives us is a mean eddy kinetic energy for each of these new climates. And we can then correlate that against each of the genesis number for each of these resamples. And what that shows is the relationship between eddy kinetic energy and tropical cyclone formation correlation. And so what we see here is that there's a strong correlation at low eddy kinetic energy, and the opposite for high eddy kinetic energy. And then over here, what we did was a similar process. We looked at the mean eddy kinetic energy against the strength of African easterly waves and the number of African easterly waves to define what the eddy kinetic energy represented. And what we found was that mainly the strength of the African easterly waves. And so that's just the peak wind speed in the African easterly wave, basically. So what this tells us then is that when we have lots of strong waves, there's plenty of precursors to tropical cyclones, and there's African easterly waves do not control the number of tropical cyclone formations occurring. But when we have too few strong waves, we have a high correlation to tropical cyclone formation, and that means that this is controlling the number of tropical cyclones coming out of easterly waves. And so in future we propose using the genesis efficiency metric up here. This is the genesis number divided by the standard deviation, or divided by a normalized eddy kinetic energy. And we propose forecasting this using a long-range forecast, and then this can be used to predict tropical cyclone formation from African easterly waves. So with that, I'll leave you with my summary and conclusions, and thank you for listening.